Okay, so this is the final packet for the for algebra, for 8th grade algebra. And it is the phase 3, and this is what the front of it looks like. And it's set up by date instead of days of doing this. So you can see the calendars here, starting on May 5th. So we're starting with quadratic functions. Again, this is a review, but you definitely need to know this before going into Algebra 2. So we start with a little bit of review of factoring polynomials. So just like the previous packet, I'm going to do 1 week at a time, and you should have already done this or at least tried it. So this will be a way for you to kind of go back and just double check your work to make sure everything is okay. So we just have some information, definitions, things like that, different forms of quadratic functions. Again, this is all review. And then we're starting off with some factoring. So again, I'm not going to do every single problem, but I will do some of the ones that I think might give you some trouble. So let's start off with one that's fairly straightforward, maybe number 1. And we're looking for common factors in each of these terms. So numbers, variables, things like that. So I see the only thing that's common is a 5. So I write that out front. And then inside the parentheses, we're going to write whatever we need to multiply that 5 by to get back to our original expression. So 5 times what will give us 5x. And that would just be x. And then looking at the second term, which is a negative 35, so 5 times negative 7, or that would become minus 7, would give us that 35. So just kind of mentally checking our work. 5 times x is 5x. 5 times negative 7 gives us that negative 35 or minus 35. Okay, I'm going to try one that has a negative coefficient in the front, maybe number 4. So keep that in mind. We're going to need to make sure that we don't forget that. So looking at the numbers, okay, numbers first. I know 6 will go into both of those. Okay, and again, if you try it, and let me just give you an example of what you could do if you don't find the greatest common factor at first. So I'm just going to say that I know I can divide both of those by 2. And then whenever we have a negative in front, we want to make sure that is the sign of the number that we factor out. So I'm going to say I have a negative 2, and then I see that each of these terms has an a, so I'm going to do that. All right, so now in my mind, I'm thinking, okay, what do I need to multiply negative 2a by to get negative 18a squared? So it would be 9a. Okay, so think about that. When we multiply those together, we get negative 18, and a times a is a squared. So that looks good. So the reason we take the negative out of the parentheses is because we typically don't want it inside the parentheses. It's just kind of best practices for factoring. All right, so then the next one, this is a positive here, so I need a negative times a negative, and then I have 12, and I don't need an a. So negative 2a times negative 12 gives me positive 24a. So now I look in my parentheses. I see that I can divide both of those numbers by 3. So that tells me that I did not choose the greatest common factor originally, but that's fine, okay? All we have to do is just factor that out. So I have that negative 2a, and then I'm just going to put a dot for multiply, and then I'm going to take a 3 out, and then I get 3a minus 4. And I just kind of fix this part in the front, so that's a negative 6, so negative 2a times 3 is negative 6a, and then 3a minus 4. And then let's see if that gets us back to the original. A negative 6a times 3a is negative 18a squared, which is what I started with. And then negative 6a times negative 4 is positive 24a. So that is our final answer. And I don't really love going horizontally, but it's how it's set up, and that's fine. I'd rather go vertically, just keep working underneath. But anyway, there's our final answer. Maybe the last one we can do So looking at these numbers, I know a 5 will go into each of these. And I believe that's it. So 5, and then what about the y? So what's the highest exponent of y that we can factor out? That would be y squared. Oops. That's outside of the parentheses. Got ahead of myself. Y squared. Okay. So 5y squared times what will give us 20y to the 4th. Okay, so 5 times 4 will give us 20, and then y squared times y squared will give us y to the 4th. Then we have minus, and then 3y, and then plus 6, and that's it. Because 6 times 5y squared will give us our 30y squared. All right, so that's a little bit of polynomial factoring. Okay, so that's what we did as our foundation, then we built up to factoring quadratic. So now we're looking at the opposite of factoring, and that's multiplying. So there's an example at the top. And again, there are other methods of doing this. I prefer using a method that we learned years ago in math, and that is the distributive property. So distributive property 2 times. All right, so let's try the first one. So basically I'm going to take, I can rewrite this as x, so this first term, times all of that in the second set of parentheses, and then the second term, including the sign, times the second quantity. So that's distributive property twice. Okay, so we just start from left. X times x is x squared. X times -1 is negative x. And then we go to the second part. -1 times x is negative x. And then -1 times -1 is positive 1. And then we have 2 like terms that we need to combine. And that's going to give us x squared minus 2x plus 1. All right. Let's try another one. Maybe number 8. So again, we don't, at this point, we shouldn't have to write this middle step, but I'm just showing you that this is how we are doing this without writing it. So we're just kind of doing this mentally. We're taking the first term times each of those, and then we're taking the second term times each of those. Okay, but if we don't want to do that in our head, or we just don't really see it, or it's confusing, then let's write it out. So 2 distributive properties. So we start on the left. 2x times x is 2x squared. 2x times 8 is 16x. And then -9 times x is -9x. And then -9 times positive 8 is -72. And then, just like before, we have like terms right here and right here. And then we put it all together. We get 2x squared. And then 16x minus 9x is positive 7x and minus 72. So how could we check our work? I mean, you can look at our answer and try to factor that back into the original, but I mean, if you're not quite sure of what you're doing, it may not work. So, or you may get something that's wrong despite your answer being correct. So what we can do is just take Desmos, okay, and graph it. So just type in the original expression with the parentheses, just like it is. All right, that's going to give you a graph. It's going to be a parabola. And then take your answer and type that in as well. And you should see that they overlap exactly. Okay, so we have tools to do this. So I don't know, I guess I can just show you an example really quick. So we're going to use Desmos. So we have 2x minus 9 in parentheses, okay, 2x minus 9, and then times x plus 8. Okay, so there's our graph. All right, and then we ended up with 2x squared plus 7x minus 72. 2x squared plus 7x minus 72. 2x squared plus 7x minus 72. All right, if we toggle those on and off, we see that it's exactly the same graph. And it should be, because we did it right. So if it's not the same, then there's a problem somewhere. And most likely, it's just due to multiplying a negative incorrectly or forgetting about a negative, something simple like that. So again, go through these, check your work using Desmos, just to make sure that everything is good. All right, and that's all for the first day. So these are a lot shorter than before. Again, we'll just cruise through a week so that you can go back and check your work. So continuing with quadratic functions, factoring, trinomials this time. Okay, so again, this is just review. All right, and there's a lot of methods here. So we learned, so they're giving you two examples here, kind of like organizing how, how we would do this in our heads. We've done factoring using the area model. And a lot of you, by the time you get to the end of our lesson, we're pretty good at kind of skipping some of those middle steps or using some of those other tools. So factoring each of these, we know we're going to have two binomials that we're going to multiply together to get the original trinomial. And then the first term is b squared, so we know that's b times b. And then looking at the signs of the original trinomial, that's going to give us a clue as to what we need to do when we factor. So the second sign is a negative. So no matter what, that means these signs are opposite. It could be, you could put the plus first and then the minus, or it could be minus and plus. It doesn't matter, but they have to be different, because when we multiply the numbers in this position, when we multiply those together, we have to get a negative. So the only way to do that is a positive times a negative. Okay, so we know that. And since they're different signs, we're going to end up subtracting those two numbers to get our 2b when we do our combining like terms step. So again, you have to be good at multiplying binomials, which we did on the previous day, in order to even understand this. All right, so let's think about this. So factors of 15 that we can we can subtract to get 2. So 1 and 15, we subtract that, that's 14. That's not going to work. So how about 3 and 5? If we subtract 3 from 5, we get 2. So that will work. So it's 5 and 3. Okay, but it's very important that we know where each of those goes. So we're going to end up with a positive number when we combine like terms. So the larger of those two factors has to go with the plus, and the smaller goes with the minus. So let's just multiply this out just to make sure. We could also graph it and see if we get the same. So b times b is b squared. B times negative 3 is negative 3b. 5 times b is positive 5b. 5 times negative 3 is negative 15. We combine those two, and we get b squared plus 2b minus 15. Okay, so that's what we started with. So then this must be our factors. All right, I'll do one more for you. And then, again, this is all review, so you should be able to do this. Let's try this one here. So again, when the leading coefficient is 1, which is this one right here, it makes it really nice. So y and y, that's the only way we can get y squared. So that takes that kind of guesswork out of the way. All right, so again, our second sign is a negative. That means we have opposite signs in here. Oops. And you could write the minus first and then the plus in the second one. That's fine. It doesn't matter. All right, so now we're thinking factors of 48 that we can subtract to get 13. So factors of 48. So you can write this out. So, we have 1 times 48, 2 times 24, 4 times 12. Okay, so I'm just using the doubling and halving method. But keeping in mind, we're going to need to subtract those to get 13, and none of those are working so far. So I have a feeling we're going to need something a little bit different. And what's in between here, we have 3 times 16. 3 times 16, that's 48. And we subtract, we get 13. So that's going to work. So 16 goes with the plus because we want our final term to be a positive. And then the other factor goes there. So let's check our works. We get y squared. So y times y is y squared. Y times negative 3 is negative 3y. 16 times y is 16y. And then 16 times negative 3 is negative 48. So let's just make sure we have this. So we get y squared. Negative 3 plus 16, that's positive 13. Y minus 48. That matches the original. So that must be our correct factors. Okay, again, all leading coefficients are 1. And just a note, the 2 examples that I did, the second sign was a minus, okay? But if we have one that's a positive, I'll just start this one for you. So x and x, and now this second sign is a positive. So that means the signs that go inside have to be the same, because the only way to get a positive is when we multiply a negative times a negative or a positive times a positive. So next is looking at the first, or the sign for the middle term, and it's a minus, okay? So that will be what goes in here. So if that last sign is a positive or plus, then the sign of the middle term is what goes in our factors. And then when we think about our factors and how do we get that 8, so it's this time we're going to add the 2 factors of 12. So what factors of 12 will add to 8? So we have 1 and 12, we have 2 and 6, 3 and 4. So which of those will add to 8? And then we put those in there in the parentheses after the subtraction sign, and that's it. Okay, so these are kind of like brain teasers, but yeah, they're logic puzzles, kind of interesting. So to get you to kind of deduce information based off of things that we have. And again, these are really cool to get you to think in different ways. And you can go through this introduction. There's actually a website at the bottom there that has tons of these. So if you really like these, or if you just want more practice to kind of get a feel for how it goes, and online, you can actually click in the boxes, and it's a little bit faster than doing it on paper. All right, so go through this example, try it out, and there's more resources down at the bottom there, the brainzilla.com, and then here's one for you to try. Okay, so moving on to the next day. Again, more and more with quadratic functions and solving for zeros. So that's kind of putting everything together that we've been practicing and then applying it to these graphs. All right, so we want to solve quadratic functions by factoring. And it says use the zero product property. So remember, zero product property is applied in this example. So if we look at this, here's our original equation that we're trying to solve, but we want to bring everything to the same side so that everything equals 0. So it looks like those functions that we just factored. And then we do that by subtracting 27 on both sides. So that gives us this. Okay. And then that's equal to 0. And what are we looking for? We're looking for these points on the graph right here. So remember, this is usually equal to y, but when y is 0, that's any point along the x-axis. So we're looking for those 2 intersection points, or the x-intercepts, or the roots, or the zeros. Okay, so that's what we're trying to find. And we do that by setting this equal to 0, and then we factor just like we did. So we get our factors, and then these are factors, right? So we're multiplying. So if we multiply two numbers together, how are we going to get 0? Well, one of those numbers has to be 0. It has to be. Okay, so that's the zero product property. So then what we do is we just split it up and we find out, okay, so if this factor is going to be 0, then what does x equal to make that 0? So x minus 3, if we want that to be equal to 0, so you set it equal to 0, and then we solve for x, and x has to be 3. Okay, so that's one possibility. So if x is 3, then this expression, or this function here, will equal 0. Okay, but that's not the only option. We have this other factor, x plus 9. So what value of x would make that become 0? And that would be x equals negative 9. Okay, so again, if x equals negative 9, then that entire function will be 0. Okay, and again, that means it will intercept, well, this is not the same graph, but it will intersect at, let me just draw it for you. So it'll intersect at 3 and negative 9. So the parabola will be something like that. So it'll go through positive 3 and negative 9 on the x-axis. Okay, so we're looking for those intersection points right there. All right, so again, this is just an example for you to reference. Okay, so that's what we're going to do. We're going to find those points, and we're going to do it by factoring. So we don't need to graph it. We're just going to factor, use zero product property, and then solve for those variables. Okay, so let's try the second one. The first one's done for us. So first step is to factor in any way that you know how. All right, so m and m, that last operation is subtraction, so these are going to be opposite signs. All right, and then we're looking for factors of 90 that will subtract, because these are opposite signs here, that will subtract to give us, well, what is that number? That's a 1. So factors of 90 that will give us 1 when we subtract. Okay, so how about 9 and 10? 9 times 10 is 90, and then 10 minus 9 is 1. So it's a positive, so let's put the larger number next to the plus, and the smaller of those two factors next to the minus. So I'm just going to multiply this out just in case I made a mistake. So that's m squared minus 9m plus 10m minus 90m squared. This is just my quick check before I go on so I don't continue making mistakes in my problem. Okay, so that's good. All right, so let's bring this here, and we're going to set each of those factors equal to 0. Okay, so let's do the first one. So m plus 10 equals 0. Subtract 10 on both sides. I get m equals negative 10. So there's one of our x-intercepts, or one of our solutions. And then the other one, m minus 9 equals 0. Add 9 to both sides. I get m equals 9. All right, so if we graph this, which you could, using Desmos, graph it, and then those 2 points that we found should be where the curve crosses the x-axis. So let's just try that. So we have m squared plus m minus 90. M squared, so I'm going to use x instead of m. So I'm just, before I didn't do the y equals, but you really should. So x squared plus x minus 90. All right, so there is our graph. Just double check. Okay, looks good. So we want to know the points where the graph crosses the x-axis. And we click on it, and we get 9, 0. So the y value is 0. That's what it means to set that equal to 0. And then we have 9 for our x value, and over here we have -10 for our x value. So going back, we should have m equals 9 and m equals -10, and we do. So that's good. All right, so again, it's just a practice of factoring and then taking it one step further and finding those actual solutions. So I don't know if we should do, maybe we do one more with a little bit different signs in our original function. So let's try the one right below that. So let's factor first. Okay, so we have n and n. And then this sign is a positive, so that means whatever goes in here are going to be the same, and that sign is this one. So let's say minus in both of those. And then factors of 9 that will add to 10. So that sounds weird, right? How are we going to get a bigger number? 3 times 3 comes to mind, but 3 plus 3 is 6. The only other option we have is 9 and 1. 9 plus 1 is 10. Okay, so again, just mentally thinking this through. N times n is n squared. N times -1, that's negative n. And then -9 times n, we put those together, we get -10n. And then the last number is -9 times -1 gives us +9. So everything checks out. All right, and then our last step is to separate these and set each of those equal to 0. Solving, we get n equals 9. And then the other one, we have n minus 1 equals 0. Add 1, n equals 1. So if we graph this, we would see that the parabola crosses at 1 and 9. All right, so this is going to be the last day for this week. Okay, so here we have special cases, and this is the difference of squares, and there's an example up above. So when we factor these, they factor a little bit differently, but you can still think of it as the same as before. So let me do it like we have been doing it, and then maybe we have a little bit quicker way, like a shortcut. So I'm going to rewrite this. So x squared, and then I'm going to put a 0x, because there is no x, and minus 36. So this might help us to kind of understand the old style, not the old style, but the factoring method that we've been using. Okay, so x and x, that's fine. All right, so now we have a minus for this third symbol, or not symbol, but operation. And that means this is going to be a plus and this is going to be a minus. Okay, so now we want factors of 36 that when we subtract, we get 0. So what is that going to be? 3 times 12, no. 6 times 6, 6 minus 6 is 0. So a 6 goes there, a 6 goes there, and that's it. Okay, you can multiply it back out. X times x is x squared. X times -6 is -6x. 6 times x is +6x, and then -36. So when we combine these two, that will make 0. So we end up with x squared minus 36, which is what we started with. All right, so we're good. So it says to solve, right? We are solving quadratic still, so that's why it's equal to 0. So we do the same thing. We take each of these and we set them equal to 0 on their own. So we have x plus 6 equals 0 and x minus 6 equals 0. So subtract 6 on both sides, we get x equals -6. And then add 6 for this one, we get x equals +6. Again, let's graph it and let's see if we get the same thing. So x squared minus 36. Okay, so y equals x squared minus 36. All right, and so all of these are going to be symmetrical about the y-axis, or the axis of symmetry is going to be the y-axis. And it crosses at 6 and -6, just like we found. All right, so this is not how we're going to do all of them. So if we look at these examples, what are we really doing here? So it's called the difference of squares. So when we factor, all we need to do is take the square root of the original terms. So the square root of x squared is x. Okay, we put an x and an x. Square root of 36 is 6, so we put a 6 and a 6. And then the signs have to be opposite. And that's it. So I don't really like memorizing shortcuts, but I did show you how you can do it without any memorization. Okay, we set it up just like we did before, except it just has a 0x for that middle term. But when you get to problems, with a little bit bigger numbers, it's nice to be able to kind of get to our answer a little bit more quickly. So looking at the last problem, so I'm just going to focus on this term here and then this term and not that symbol in the middle. So I set up my factors. And then 81a squared. So what's the square root of that? Square root of 81 is 9. Square root of a squared is a. Okay. And then always we're going to have opposite signs. You could put, it's not opposite. You could put the minus first. It's fine. Okay, so a plus and a minus. And then the square root of 144 is 12. And the square root of b squared is b. Okay, multiply that out or graph both of those just to see if that's correct. Okay, so now I'm sure my factors. Now I'm going to take each of those and set them equal to 0. So I have 9a plus 12b equals 0. And then 9a minus 12b equals 0. So I pause for just a moment because it does say to solve. And that's why they set these up to be equal to 0. So going through, I can see, okay, number 1 is fine, number 2 is fine, number 4 is fine, but 3, 5, and 6, we have a small problem. There's 2 variables, okay? So we could solve for one variable in terms of the other, but that's not really what we would be doing in class. So if we were told, like, for example, b equals some value and solve for a, or a equals a value and solve for b, we could do that. So I don't really have that information. So I'm just going to solve for a, okay? Solve for a in terms of b. So I want a isolated. So let's subtract 12b on both sides. So I get 9a equals negative 12b. And then we're solving for a, so we divide by 9 on both sides. We get a equals, simplify over here, divide by 3. So we get negative 4b over 3. So that's an a over here. Okay, so there's 1. And then we add 12b both sides. So we get 9a equals positive 12b. Divide by 9. A equals 4/3 b. And again, if we knew what b was, we could substitute that and get an actual number for our intercepts. Honestly, these are just mistakes, I would say, and there really shouldn't be this equals 0 here. Anyway, it just would say factor, okay? And then our answer would be just this, and that's it. Just practicing difference of squares. Okay, so here we have perfect squares this time. So there's some examples at the top, and a perfect square is like an actual square where the sides are the same. So then the area would be side squared or 5 squared. So the same number times itself. But in this case, we have a binomial times itself. Okay, so let's take a look. We're just going to solve. Okay, that's our goal, solving. So don't do any more work that's necessary. So the first one, what does this mean when we have this, the exponent out front or out outside the parentheses? It just means whatever's inside the parentheses times itself. And now it looks like the problems that we've done before. We take each of those, set them equal to 0. And they're exactly the same. So we have repeating roots. So what does that even mean? Okay, so let's look at a graph. It'll be easier to see. So we have x plus 2, so y equals, in parentheses, x plus 2, close parentheses, and square. Okay, so now it's a parabola. All right, so the number we found was minus 2. So basically, we don't have two y-intercepts or two x-intercepts anymore because it just comes down and barely touches the x-axis. So if we think of how this would be if we had like that, okay, so we have two distinct x-intercepts. So as we move this up, or as those x-intercepts come closer and closer together, they basically just kind of collapse onto each other, and we end up with the same root. So x minus 2, or x equals minus 2. And that's it. So these are another special case. So that's how we would do that one. Some of these are factored for us, but if they're not factored, we need to factor them. So let's say number 4. So we have x. This sign is plus, so it's going to be the same sign in both of those, which will be this one. Okay, and then factors of 64, that will add to 16, and that's going to be 8. It is going to be the same because these are the perfect squares, so it's the same thing times itself. So then x plus 8 equals 0, x equals negative 8. Okay? And that is it for the first week. And another logic puzzle for you to work on. If you are struggling with these, then please reach out and I can go through an example for you. All right, that's all.